All right, this is the second video for section 13.5. All right, so we talked about what the sine and cosine graphs look like, what the tangent graph looks like. The sine and cosine graphs have basically the same properties. Everything about them is essentially the same, just a little bit of a shift to go from one to the other. And as we talk more about these functions, you'll start to see that and see how they're very much related to each other. The tangent graph is a little bit different. So, when we were talking about the graphs of these trig functions, there's a couple of phrases that always pop in. So take a second, hit pause, copy these things down, and we'll talk about it. All right, amplitude. Basically, you know, when we talk about amplitude, we're only talking about sine and cosine. Sine and cosine only. You can have this amplitude in a tangent. I mean, you'll see that where the amplitude comes from in the equation, it does something to the tangent graph, but when we talk about the tangent function, we don't really talk about amplitude. Okay, so for the sine and cosine graphs, those are those nice looking waves. The amplitude is essentially the height of the wave, sort of, okay, because we can shift these waves up or down in the function, and so the better definition is that half the distance between the minimum and the maximum. And so, you know, if we have this nice looking wave for the sine graph, where this goes from 2 down to -2, the distance between the max and the min is a distance of 4, but the amplitude is half of that. So we have an amplitude of 2. All right? So that's what we mean by amplitude. A phase shift is, like it says, it's a horizontal shift. So essentially just taking this and sliding it left or right. Okay, those are their shifts, left or right. The period of the function, that's the horizontal distance it takes for the graph to repeat itself. So let's see if I can mess with this here. Basically, we're scrunching this in so it repeats itself in a shorter distance, or maybe it repeats itself in a longer distance. I got some better graphs to look at here, so I'm just giving you a rough idea of what that means. The vertical shift is just up or down, okay? So, what we're looking at, the transformation of the trig functions. We are just talking about sine and cosine. So, this equation and this equation, they are exactly the same thing. The only difference is the trig function, sine and cosine. But these other values, a, b, c, and d, they all mean the exact same thing for the sine or cosine graph. All right, a is the amplitude. Okay, so when you see that number a out in front, like if we had a 5 times the sine of x, our amplitude is 5. The value of c, okay, notice how we're subtracting from x. Just like all the other transformations we've talked about. When we subtract from x, we're talking about a shift. So if it's x minus 5, whatever the cosine of x minus 5, this is a shift right 5. If it was x plus 5, shift left 5. Okay, same thing we've talked about all year long. The period is coming from this value of b. Okay, it's what you're multiplying the x value by. The period is actually 2 pi divided by b. Okay, so it's that weird horizontal stretch compression kind of thing where the scale factor was 1 over the number you're multiplying the x value by. Same thing here, 2 pi divided by b. And that last number d, as always, we're adding it to the parent function. That's shifting it up or down. All right, so let's take a look at some graphs. Let me reset where we were. Okay. So now, what we are looking at here is the most basic sine function. All right? It has a amplitude of 1. Okay? You can see the maximum is at 1. The minimum is at 1. Like here's the maximum. It happens at an angle of pi over 2. The y value is 1. Here's a minimum. The y value is -1. All right, so we have these max and mins. The distance between the max and min is 2. Half of that, we got an amplitude of 1. Let me get rid of these points here. All right, so in that last slide that we looked at, the A value told us our amplitude. Okay, so it's the number you're multiplying the trig function by, and really just sine or cosine. So what I'm going to do is, right now it's at 1, so we just have 1 times the sine. So what I'm going to do is just slide this over, and you can see how as the A value gets larger, right now it's at an A value of 3, you can see how the graph really isn't moving. What's happening is the waves are getting larger. All right, we got a maximum at 3, a minimum at -3. So distance is 6, half that, we got an amplitude of 3. That's our A value. Okay, let me get rid of those. And so we can slide it, make the waves as tall as we wanted to. If it's a negative, you're throwing a negative out in front, so now we're talking about a reflection, but we're not going to concentrate on that too much. Okay, now, so the A value, it's your amplitude. All it's doing is just taking those waves, and if you think about a lake, it's making the lake rougher or it's making the lake calmer, okay? You're making those waves much taller or much shorter with the value of A. That's your amplitude. Now, looking at this generic equation in the highlighted, the x minus the c, we're subtracting from x, that's our shifts left or right. So, right now, c value is 0, so we're not subtracting anything from x, so we're not shifting it. But, all I'm doing is just making the waves move left or to the right, okay? That's what the value of c is, that's what a phase shift is. It's just shifting the graph left or right. Now, right now, what I've got is c values. I'm just going between 0 and 10. Normally, what you're going to see in the equation, and you'll see some examples in a minute, that c value, it's an angle measurement. All right, it's going to be like x minus 90 degrees, or it's going to be x plus pi over 3, whether it's degrees or radians. All right, so the c value, it's going to be an angle. That's what a phase shift is. You're shifting this graph a certain number of degrees or a certain number of radians left or right. Okay, so that's your amplitude and your phase shift. Now, let's go to the cosine graph. Again, it doesn't really matter if we're talking about sine or cosine. Now, in this cosine equation, I got b times x. So b, when you're multiplying the x value by a number, that's your horizontal stretch or compression. And so when we are stretching this or compressing this, trig functions, the sine or cosine, that's changing the period of the function, how the horizontal distance it takes the graph to repeat itself. So now, right now, this is just the most basic cosine function. Okay, the graph starts at a y value of 1, it goes down to -1, back up to 1. This is a horizontal distance of 2 pi or 360 degrees, okay? That's the period of this graph. So now, if I change this value of b to go from 1 to 2, look at what happened to the graph. Okay, it got compressed in. So now, we're going from here to here. We started at a maximum, went down, back up to that maximum. That's a distance of pi, or 180 degrees. So what we've done is basically shrunk this graph. We went from 2 pi, a period of 2 pi. When that b value is 2, we shrunk this graph, okay? Another way to think about it is this graph is repeating itself twice in that same distance. So the new period is 2 pi divided by 2, which is pi. Okay, we've got a couple of ways we can think about this, but this equation, that generic 2 pi divided by b, this is what is giving us the period of a function. All right? With a b value of 2 in the equation, what we're looking at is cosine of like 2x. All right? You could think of it as the graph is going to repeat itself twice as fast. All right? Or it's taking half the distance to repeat itself. Those kind of mean the same thing, just how you look at it. All right, so that's the idea of the period. If we change the b value to 3, let me erase some of this stuff. If you change that b value to 3, now we're looking at the graph repeating itself 3 times. It did repeat itself once in 2 pi, or 360 degrees. Now, it's going once, twice, 3 times in that same distance. So we've cut the period down to 2 pi over 3. or 120 degrees. So every 120 degrees, this graph is repeating itself. Okay, that's the idea of what that value of b does in the equation. Okay, it's changing the period by 2 pi divided by the value of b. Now, let me bring that back to normal. Let me clear some of this ink out of the way. The last thing we talk about is the value of d. Okay, when you add a number to the parent function, that's your shifts up or down. So right now d is 0, so we're not shifting up or down. But if I make d a positive 1, I just shifted that graph up 1, up 2, up 3, up 4, up 5, whatever. You can go in the negative direction, you're just shifting it down. So that d value, all that is just shifts up or down. Okay, so that's your transformations for sine and cosine. And I'll come back and do some examples here in the third video, but just talking about the ideas and taking a look at these graphs. The last one to look at is the tangent function. Now, the amplitude. We don't really talk about amplitude when we are dealing with the tangent function. So the a value, what it does is basically it kind of either flattens out these graphs so they look more linear or brings them closer to the x-axis there. All right, that's what the a value does, but it's not a amplitude. We don't talk about amplitude with tangent function. The value of b, that is changing the period. Right now, we've got these vertical asymptotes every 180 degrees. Okay, so the graph repeats itself in this 180 degree distance. If I change my value to b, it's going to repeat itself twice in that same distance. And you can look at it here. Let me change the color. Now we've got there's a vertical asymptote. Here is a vertical asymptote. Here is a vertical asymptote. And they got it a little bit shifted here. But you can see how this space, this distance, is the same as this distance. So if you shift the green over a little bit so that the outer green ones match up with the blue ones, you've got 2 periods in that same distance that there was only 1 period. Okay? And we can keep on going. With 3, now the graph repeats itself 3 times in that same 180 degree distance. We can do a whole bunch. But let's go back to the basic one. Okay? So let me clear these green ones out. Actually, let me just slide them in. Let me move that back to b equals 2. You can see how this graph is repeating itself. The distance from here to here and here to here. There's 2 of those in that same 180 degrees that when the period was 180 degrees, now it's repeated itself twice because of that b value. So when we're talking about the tangent function, the period is going to equal 1 pi over, not 2, sorry, over b, or 180 degrees over b. The value of d, that's just going to shift these graphs up or down. Kind of looks weird, but it's just shifting all those things up or down. So that's what the tangent does. All right. I know that was a long video, but a lot of stuff to look at and a lot of stuff to mess around with. So the third video, just a couple minutes of looking at an example or two. Please watch.